We're going to talk about permutations, and permutations are basically the number of ways that you can accomplish something when order matters. And we'll explain that a little bit later on. But the alternative when order doesn't matter is called combinations. But permutations, the number of ways that you can accomplish something when the order matters. And so we'll do an example here. Let's say you have 3 tasks that you have to accomplish. And we're just going to say that these are eat, sleep, and work. How many ways can you order these tasks? So we have 3 tasks that we have to do, and the question is about how many different ways can you do them. So for example, we can eat first, then we can sleep, and then we can work. Or we can eat first, we can work, and then we can sleep. We can also sleep first, eat, and then work. We can sleep, work, and then eat. Or we can work first, eat, and then sleep. Or we can work, sleep, and then eat. And that's an exhaustive list of how the order that we can do each of these 3 tasks. 1, 2, 3, 4, 5, 6. There's 6 different ways that we can accomplish these 3 tasks. It just depends which one we want to do first, second, and third. But depending on how we order them, there's 6 different ways that we can do it. So when you have a small problem, like with only 3 tasks, you can actually write them out and figure it out. Add them up. 1, 2, 3, 4, 5, 6. There's 6 different ways that we can accomplish this. But as this number grows, it's not feasible to just list everything out. So mathematically, the way that we can figure this out is, so the first task that we're going to do, we have 3 possibilities. So we're starting from a clean slate. We can either eat, we can sleep, or we can work. There's 3 different possibilities for that first task. But once we've chosen that task, so once we choose to eat, for our second task, well, there's only 2 we can choose from. We've already eaten, so now we only have 2 things that we can choose from. We can either sleep or we can work. So for our second task, once we've chosen our first task, there's only 2 possibilities. Then once we've chosen our first task, we've chosen our second task, there's only 1 task left. So there's only 1 possibility. So if we choose to sleep and then we choose to eat, the only thing we have left is work. There's only 1 thing left. If we choose to sleep and then work, there's only 1 thing left. We have to eat. So for the last task, there's only 1 possibility. So our first when we're starting with a clean slate, the first thing we choose to do, we have 3 choices. But once we choose that, for our second task, we only have 2 choices. And then once we've chosen our second task, for our third task, we're only left with one alternative. So there's 3 in the first choice, 2, and then 1. When we multiply these together, 3 times 2 times 1, we get 6. And that was the same number when we enumerated them, 1, 2, 3, 4, 5, 6. So when you enumerate them and count them up, you're going to get the same as if you think about it mathematically, where how many choices do I have for that first item? Then given that, how many choices do I have for the second item? Given that, how many for the third? And then you just multiply them together. So just think logically about how many choices you have given that you've already selected something before it. Let's do another example. Six people sit on a bench. how many ways can 6 people sit on a bench? So we can enumerate all of this, or we can just think. So we have, here's our bench. There's 6 seats on the bench. So if we have 6 people, who can sit in that first spot? Well, any 6 of them. So there's 6 possibilities for that first spot. But once someone sits down, they can't sit in any of the other spots. So once they sit down, how many people can possibly sit in the second spot? There's only 5, because there's only 5 people left. Once those 2 people have sat down, there's only 4 people left. Any one of the 4 can sit down. So there's 4 possibilities. Once these 3 people have sat down, there's only 3 people left standing. Any one of them, so any one of the 3 can sit down. So there's 3 possibilities of someone sitting in that spot. Now there's only 2 people left. So there's 2 possibilities of someone sitting in that spot. And then there's only 1 person left standing, and he or she has to sit in the last spot. So how many ways can 6 people sit on a bench? 6 times 5 times 4 times 3 times 2 times 1. You just multiply it together. So you first figure out how many people can actually sit in each spot, and then you multiply it. You throw that in your calculator. There's 720 different ways that people can sit down. So you don't want to obviously enumerate each one of them, because you're going to have to do that 720 times. That's why you have to think of it mathematically. How many people can sit in the first spot? How many, now given that someone sat down, how many can sit in the second spot? Etc. And then you just multiply it all together. Now, let's do one that has a little bit of a twist on that, where it's not everyone that's included. So let's say a museum has 7 paintings. How many ways can they put 3 of them on the wall? So they have 7 paintings, and they want to hang 3 of them. So here's your first painting, here's your second painting, here's your third painting. So again, think logically. We have 3 paintings. Of the 7 paintings, how many of those can we choose to put in the first spot? Well, any of the 7 we can put in the first spot. Now, given that we've hung one of them, how many are left? There's 6 paintings left. So we have 6 to choose from to put in the second spot. Now that we've hung 2 of them, there's only 5 paintings left. Any one of the 5 can go in the third spot. So how many ways can you put 3 on the wall? 7 times 6 times 5. If you throw that in your calculator, there's 210 different ways that you can put 3 paintings of those 7 on the wall. So this is different in that we didn't go 7, 6, 5, 4, 3, 2, 1 because we were only looking for 3 of them. But again, think logically. How many can you put in the first spot? Given that, how many can you put in the second spot? Given that, how many can you put in the third spot? And then you're done. You don't have any more spots. And then you just multiply them together and you get 210. Let's do another one that's similar to this. You have a security system that has 4 different digits. So how many different codes can you have? And so this is where order matters. This is why we're doing permutations versus combinations. So for example, if you have a security system and your code is 5691, that's different than 1956. These are the same numbers, but the order matters. When you're doing combinations, the order doesn't matter. So these would be essentially the same. But in permutations, these are different because the order matters. So, and the digits are from 0 to 9. So there's 10 digits we can use because we can use the 0. So how many different ways can we have a code that has 4 digits in it? And each one has to be different. We can't use the same one. So the code can't be 2239 because we can't use the same digit. So we have 4 digits. We have in our code. We can choose from 0 to 9. So there's 10 digits to choose from. So for our first digit in our access code, how many digits can we choose from? Well, we can put a 0 in, we can put a 1, 2, 3, 4, 5, 6, 7, 8, 9. We can put any of those 10 digits in our first slot. Now that we have that one, how many can we put in the second? Because they have to be different, we only have 9 choices now because we've used one in the first slot. Now that we have our first 2, there's only 8 left for our third slot. And similarly for our fourth slot, there's only 7 possible digits that we can use. So, how many ways can we have a 4-digit security system access code? 10 times 9 times 8 times 7. If you throw that into your calculator, you're going to get 5,040 different ways that you can have a 4-digit access code. Let's say that we have a password. That are not digits, but they're letters. So, how many ways can you have an access code using 4 different letters? So again, we have 4 letters in our access code, so it might be S, N, B, D, whatever. 4 different letters in our access code that we're going to punch into our access code. So there are 26 letters. So once we choose, so for our first letter, we have 26 letters we can choose from. But because they have to be different, we only have 25 letters for the second, 24 letters for the third, and 23 letters for the fourth spot. So again, we're just going to multiply this out. You throw that in your calculator, 358,800 is the answer to how many different ways we can have a 4-letter code to our security system. I'm going to pause just a second and put a problem up on the board. Okay, I put a problem up on the board. 5 people want to sit on a bench. One person wants to sit on either end of the bench. So one person says he has to sit on the end, but he doesn't care which end. How many ways can the 5 people sit on this bench? So you have 5 people. One is imposing restrictions that he sits on the end. So how many ways can these 5 people sit on the bench? So you have 5 spots. And so let's say the person sits on this end. So there's 4 people left. So how many choices do you have for this spot? You have 4. How many choices for this? Well, once this guy sits down, there's only 3 people left, so you have 3. How many choices are there for this spot? There's only 2, and then there's only 1 person standing, so he has to sit there. So, in this scenario, there's 4 times 3 times 2 times 1 equals 24. There's 24 ways that the people can sit on this bench because this guy is fixed. But all these guys can move around in 24 different ways. So there's 24 different ways that these 5 people can sit on the bench. But that's only if he sits on this end. What if he sits on the other end? Well, we'll start here again. Just think logically. So, how many people are available to sit over here? There's 4. Once that person sits down, there's 3 people left. Any one of them can sit here. Once he sits down or she sits down, there's only 2 of them left. Either one of them can sit here. And then there's only 1 person standing. So, if the person sits on this end, there's 4 times 3 times 2 times 1. There's 24 ways that the people can sit if the guy sits over here. So, there's 24 ways if he sits here. There's 24 ways if he sits here. So, how many total ways are there? You just add that up. 24 plus 24. There's 48 different ways that these 5 people can sit on that bench.